All right, well, welcome to the Unit 4 review video. I've never done this before, so this is my first time, and I'm excited to go through the entire review with you. And if you just missed part of it or you don't understand a few questions, then I would suggest fast forwarding this unless you just want to spend the entire time going through every question with me like I were side by side with you and working with you. Hopefully this video helps, but I'd like some feedback, so make sure to tell me in class whether you think this video works or not. Okay, so for number 1, it is in standard form. So standard form means if I want to find my axis of symmetry, then I need to find x equals negative b over 2a. So in this case, my b value would be negative 6. So a negative 6 would be a positive 6 over 2 times a, so 2 times negative 3, which gives me a 6 over negative 6, a negative 1 value. So axis of symmetry is always an x value, x equals negative 1. Then to find my vertex, I'm going to need to plug in my negative 1 value into my original equation. So negative 3 times negative 1 squared minus 6 times negative 1 plus 3. So when you put that in the calculator or in your head, you end up getting 6. So my vertex is at negative 1, 6. So I'm going to go ahead and plot that on my graph. I go left 1, up 6. Right here, you can kind of see that. Then it says, does it have a maximum or a minimum? So if my graph opens down, that would mean it's a maximum, and if it opens up, that's a minimum. In this case, since my a value is a negative, that means that it will be opening down, so I would have a maximum value. Okay, the next thing is y-intercept. That is when you plug in x equals 0. And that works for every type of form. So when x is 0, I would get a positive 3. So my y-intercept is at 0, 3. So I can go ahead and plot that as well. And reflect that across the axis of symmetry. And then I'm going to go ahead and connect the dots as best I can. There we go. All right, for domain and range, domain for all parabolas is always negative infinity to positive infinity. And then the range really just depends on whether you have a maximum or a minimum. So range I always read from bottom to top. So I would start from the bottom and it would go out to negative infinity. So parenthesis negative infinity. And then it would stop at my y value, which in this case, my y value is a positive 6, and then there will be a bracket. Then it asks us to put this in vertex form. So if I were to convert this to vertex form, what it's asking me is to put my a value, my h, and my k. My vertex is hk, so I can plug that in. And then my a value stays the same. So every single form of the equation of a parabola has the same a value. So I would say y equals, my a is negative 3, parenthesis, x minus h, so plus 1, squared, plus 6. So my h and my k go here, and my a value stays the same. Then it says describe the transformation. So the things you have to decide when you're describing the transformation is, does it reflect the x-axis? Yes, it does, because my a value is negative. So reflects x-axis. Then I look at my a value. Is it stretched or compressed? In this case, my a value is greater than 1, so I would say it is stretched by a factor of 3. Then is it left, right, up, down? So left 1 unit, and it is up 6 units. Left 1, up 6. Okay, let's look at number 2. Number 2 says 1/2 x squared plus x minus 3. Axis of symmetry, I'm going to do the same thing. X equals negative b over 2a. So in this case, x equals negative 1 over 2 times 1/2. So I would end up getting negative 1 again. When I plug in negative 1 into the original equation, I would get 1/2 times negative 1 squared minus 1 minus 3. So I end up getting my final answer as negative 7 over 2. So my vertex would be at negative 1, negative 7 over 2, which is about 3.5. For those of you that like improper fractions. I do not. Then does it open up or down? I look at my a value. My a value is positive, so it opens up. Therefore, it is a minimum. If I'm going to plot this point, I would go left 1 and then down about 3.5, like right there. Then my y-intercept, I'm going to plug in x equals 0. So when I plug in x equals 0, I get 0, negative 3. So I'm going to plot my point at negative 3. Then I can also plot a point at negative 2, negative 3. Then connect my dots. This is harder than it looks, guys. It's a beautiful graph. Okay, so the domain is always all real, so negative infinity to positive infinity. This one, the range is different because now I have a minimum value. So my minimum value is at negative 1 and then negative 7 over 2. So I would start at negative 7 over 2, comma, and goes out to positive infinity. Then for vertex form, I keep this same a value. So y equals, a value is 1/2, x minus h, so x plus 1 squared, plus k, so minus 7 over 2. Then to describe the transformation, it opens up, so I don't say that it reflects the x-axis, I just leave that alone. In this case, it has a fraction as an a value, so I would say compressed by a factor of 1/2. Then I would go left 1, down 7/2. Okay, finally for number 3, same kind of process. Hopefully you're getting the hang of it by now. We can only hope. So negative b over 2a. In this case, there is no b value because the b value would be in front of the x. So my axis of symmetry is just 0 because it would be 0 over 2 times negative 2. But 0 over anything would just be 0. Then to find my vertex, I'm going to plug in x equals 0 into my original equation. So negative 2 times 0 squared plus 4 just gives me 4. So my vertex is at 0, 4. So I'm going to put my point there. Then it opens down because the negative a value. So then I would have a maximum, kind of like number 1. My y-intercept is when x equals 0, but we actually already found that because that's also my vertex. So my y-intercept is 0, 4. Then if I want to plot this on a graph, My a value is -2, and remember my slope works for one x value away. So I could go down 2 over 1 and down 2 over 1 on both sides. But that only works once. Remember, it will not work 2 units away because it becomes exponential. So then I'm going to connect the dots, connect the dots. My domain is all real. And my range is, if I start from the bottom, so -infinity, all the way to the top, my y value in this case is going to be 4. So from -infinity to 4 bracket. So remember with range, it's always your y values, y values, y values, never the x value. Then if I were to put this into vertex form, it would be y equals, my a value is -2, x minus 0, so just x squared. You don't even have to put the parentheses, I just did out of habit. And then plus k, so plus 4. Then my transformation, it opens down, so I would say reflects x-axis. Then it is stretched because my a value is going to be greater than 1. So stretched by a factor of 2. Nope, that's not how you spell it. It doesn't go left or right. It doesn't go left or right because my vertex is at the y-axis. So I wouldn't say left or right, but I would say that it shifts up 4 units. All right, moving on. That was a doozy. Okay, number 3. This is actually in vertex form. I'm going to write vertex at the top. You do have to have these memorized. So vertex form is really easy to graph. It's one of the easiest because I have my h and I have my k. My axis of symmetry is always going to be where my h is, so x equals h. Since it is in parentheses, I would say x equals -5, so I take the opposite sign. And then my vertex would be at -5, -3. Because we have h and then k. So I'm going to go left 5, down 3. Here's my vertex. Then my y-intercept, if I plug in x equals 0, the same kind of rules apply for any type of form if you're finding the y-intercept. So if I plug in x equals 0, I get -2. 0 plus 5 is 5 squared minus 3. 5 squared is 25. 25 times -2 is -50 minus 3. So you get a -53, which is way off my graph, but that's okay. So then if I do want to graph this, I can use my a value. So I can go down 2 over 1, down 2 over 1, and then connect the dots. It opens down because my a value is negative. Then to get this into standard form, all I need to do is just FOIL this out. All I got to do is FOIL it out. So I would take, I'm just going to keep the -2 as is. And I'm going to write this as x plus 5 times x plus 5 minus 3. If I were to FOIL this out, you get -2 x squared plus 5x plus 5x plus 25 minus 3. Then I'm going to combine like terms, so -2 x squared plus 10x plus 25 minus 3. Now I'm going to distribute the -2 to all 3 terms. So I would write this as -2x squared minus 20x minus 50 minus 3. From there, I can combine these two terms together. So that would get me y equals negative 2x squared minus 20x minus 53. So something that you'll notice, just a few similarities. My a value is the same. For vertex and standard, my a value always stays the same. Also, my y-intercept in standard form is always the last number. So negative 53, negative 53. So if you're asked to do this, a good way to check is by plugging in the y-intercept, making sure that your a value is still the same. All right, for number 4, it is still in vertex form, but you'll notice that there is no k value. Nothing here. So that would just mean that k equals 0. There's nothing there. My axis of symmetry is my h value. Take the opposite sign, so x equals a positive 4. My vertex would be at 4, 0 because there's no k. So 1, 2, 3, 4. Dot right here. My y-intercept is when x equals 0. So I'm going to plug in x equals 0 into my equation, and I get 1/4 negative 4, or 0 minus 4, so negative 4 squared. Negative 4 squared is a positive 16, so 16 over 4 gives me a positive 4. So my y-intercept is at 0, 4. So I'm going to plot my point. I would have another one out here, and then I can connect my dots. Beautiful. Okay, to get standard form for this, I'm just going to FOIL it out like I did the first one. I'm going to leave my 1/4 alone, and I'm going to do that last. So 1/4 x minus 4, x minus 4. Then I need to distribute, or I need to FOIL. So x squared minus 4x minus 4x plus 16. I'm just going to leave my 1/4 out front. X squared minus 4x minus 4x plus 16. Combine like terms. So 1/4 x squared minus 8x plus 16. Now I need to distribute the 1/4. I save that for last. So distribute my 1/4 to the 3 terms. So I would get my standard form final answer would be y equals 1/4 x squared minus 2x plus 4. Good way to check. My y-intercepts are the same. My a values are the same. So checking those two things is a good way. Okay, lastly we have intercept form. So these are in intercept form. You could also call this factored form, either way. So what I mean by that is that both of the numbers in parentheses are my x-intercepts. And so I may want to go down here to x-intercepts and answer that question first, because then it'll be easier to graph once I have my x-intercepts. So I set each one of the things in parentheses equal to 0, so I take the opposite sign. So x is negative 3, and x is equal to a positive 2. So I just take the opposite signs. It's like setting them equal to 0 or solving when you're factoring. So I'm going to plot those points. I'm going to plot my negative 3, and I'm also going to plot my positive 2. You can kind of see that. My vertex and axis of symmetry is always the halfway point between my two x-intercepts, which conveniently, because I'm an evil teacher, I gave you a half number, I gave you a decimal, or a fraction, as we all hate. So in order to get that, I'm going to take negative 3 plus 2 divided by 2. And that's going to be my axis of symmetry. So you end up getting a negative 1/2. So my axis of symmetry is x equals negative 1/2. So it's kind of along these lines right here. Then to get my vertex from that, I'm going to take negative 1/2 and plug that in to my original equation. So I would get negative 1/2 plus 3 times negative 1/2 minus 2. And I'm going to cheat a little bit, and I'm going to put it in my calculator. And you end up getting negative 25 over 4. Or I think like maybe negative 3.125. So the vertex is negative 1/2, negative 25 over 4. So to graph that, I just kind of went down to 1, 2, 3, 4, 5. About here. I'm going to call this good. And then I'm going to connect my dots. I said 3.125 earlier. That's not right. It's about 6 1/4. So 6.25. Just can't add. Okay, then if I want to put this in standard form, all you got to do is FOIL. All you got to do is FOIL. So I'm going to take x plus 3, x minus 2. And going to FOIL it. So you get x squared minus 2x plus 3x minus 6. Combine in the middle. So standard form looks like y equals x squared plus x minus 6. And then you are done with that. For vertex form, it's a x minus h plus k. We've already found our vertex right here, h and k. My a value is still the same. Same for all types of forms. So in this case, it is 1. So x plus 1/2 x minus h squared plus k. My a value is the same, and then I am done. Okay, let's try one more. So this one has an a value in front. My x-intercepts in this case would be x equals negative 1 and x equals a positive 6. So opposite signs. To find the halfway point between these two, I would take negative 1 plus 6 divided by 2. And you end up getting 5 over 2. Man, I did this twice. So x equals 5 over 2. Plug that in to get your vertex. So 5 over 2 plus 1. And 5 over 2 minus 6. When you plug that in your calculator, you end up getting 147 over 4. These are not nice numbers. So vertex would be at 5/2, 147 over 4. Then if I were to graph this, oh gosh, if I were to graph this, I'm just going to plot my x-intercepts at negative 1 and a positive 6. And I know that my axis of symmetry is going to be at about 2.5. So like right here. And I'm just going to, I know 147 over 4 is a pretty big number. So I'm just going to draw my graph going up. It goes off the graph like this. And that's sufficient. If I were to put this in standard form, you are just going to FOIL it, but I'm going to leave the negative 3 till the end. So I'm going to write this as negative 3. Then I'm going to FOIL, so x squared minus 6x plus x minus 6. Then I'm going to combine my two middle terms, so negative 3, x squared minus 5x minus 6. Then save the best for last. I'm going to distribute this negative 3. So my final answer would be y equals negative 3 x squared plus 15x plus 18. Then vertex form, keep the same a value. So a value is negative 3 stays the same. X minus h, so x minus 5 halves squared plus k, so plus 147 over 4. All right, done with graphing for just a little bit. Thank goodness. Although I love graphing. Okay, write the equation of the parabola in vertex form. Vertex, meaning y equals a x minus h squared plus k, with x equals negative 5 as an axis of symmetry, stretched by 3, reflected across the x-axis, down 2 units. So, if I have my vertex form, x equals negative 5 as my axis of symmetry, that means that negative 5 is going to be my h, because my axis of symmetry is always at h. Then it says, so I'm going to put minus a negative 5 would be plus 5. Vertically stretched by a factor of 3, so my a value is 3. Reflected across the x-axis, that means it's a negative. And then down 2 units, so minus 2. So y equals negative 3, x plus 5 squared minus 2. Okay, for number 8, it says factor completely. So for the first one, I need to find two numbers that, well, first I need to see if there's a greatest common factor. There is not. So I need two numbers that multiply to get 8 times negative 3, so negative 24, and then add to get the middle number, which is a positive 2. So those two numbers would be a positive 6 and a negative 4. So I'm going to use the box method. I'm going to put 8s squared in the top, negative 3q squared in the bottom. Then I'm going to put 6sq, negative 4sq. And I put SQ because that's what my middle term is. It's an SQ. So when you're using X, you put negative 4x, 6x in these two boxes. Then I'm going to pull out the greatest common factor, column by column. So I can pull out a 2s at the top. I can pull out a negative q. I pull out a negative because this box is negative. So if it's touching a negative box, then it becomes negative. Just a little shortcut. Then I can pull out a 4s, and I can pull out a 3q, positive 3q. So the final factored form would be 2s minus q and 4s plus 3q. And then I am done. For number 9, I'm going to see if I can pull out a greatest common factor. I can. They both share a 30 in common. So I'm going to rewrite this as x squared minus 9y squared. Then when you have two terms like this, and there is a negative sign in between, you have to see if you can actually take the square root of both of them. And that's called a difference of two squares, which I can. I can take the square root of x squared. I can take the square root of 9y squared. The biggest mistake I see people make is that they put x minus 3y and then they square it. But the final answer would be x minus 3y, x plus 3y. And the reason why it's x minus and x plus is if I were to distribute this back out, if I were to actually go back and FOIL this, I would get x squared minus or plus 3xy minus 3xy and then minus 9y squared. So what ends up happening is my two middle terms will cancel out. If they were both the same sign, then you would have a minus and a minus. They would not cancel out. So that's why you have a minus and then a plus. So this is my final answer. A little messy. If we look at number 10, this needs to be crossed out. This is a typo that was made. 64w squared minus 48w plus 9. Is there anything that I can pull out? Do you not think so? No. So I'm going to see if both of these are perfect squares. So if you have a perfect square polynomial, take the sign of the middle. The square root of 64w squared is 8w. The square root of 9 is 3. Take the sign of the middle. So 8w minus 3 squared. And when you're doing this on a test, you can always FOIL it back out to check your answer. Another thing you could have done is you could have done the box method just like this if you wanted to. If you did not recognize that it was a perfect square, the box method will work too. With number 11, same thing. I can take the square root, both of these, take the sign of the middle. So the square root of 225x to the fourth is 15x squared. Square root of 4 is 2. Take the sign of the middle. Squared. So these are perfect squares. How you recognize that is if the first and the last term are squares. You can take the square root of them. Then you take the sign of the middle term. If you do not recognize that they are perfect squares, you can do the box method. So I just recognized it. Sometimes you can't. It's harder to, but box method will work. Or factoring by grouping. You're going to get the same answer. Okay, number 12. This one I want us to factor and solve. Solving means I set them equal to 0. So if we look at the first one, I look to see if there is something I can pull out, a greatest common factor. In this case, I can pull out a -3. I want to get rid of this negative because I don't want a negative in front of the x squared. So if I pull out a -3, I end up getting 10x squared minus 3x plus 4, or actually be a minus 4, equals 0. Then I want to factor, so I need two numbers that multiply to get 10 times -4, so -40, and then add to get a -3. So let's see, we have -8 and 5. Do the box method. 10x squared minus 4, -8x, 5x. I can pull out a 2x, can pull out a +1, 5x, -4. So my final answer of factoring would be, don't forget about the -3, 2x plus 1, 5x minus 4 equals 0. Then I set this stuff that is in parentheses equal to 0. So I would say 2x plus 1 equals 0. So x equals negative 1/2. And 5x minus 4 equals 0. So x equals 4/5. So these are the three answers I would be looking for. For number 13, I want to put it into standard form. So I'm going to rewrite this as 12x squared minus 38x plus 16 equals 0. I'm going to pull out a greatest common factor. They all have 2 in common. So 6x squared minus 19x plus 8 equals 0. Then I need 2 numbers that multiply to get a 6 times 8, a positive 48. And then add to get my middle number, which is a negative 19. So I have negative 3 and negative 16. That will work. Draw my box. 6x squared, 8, negative 3x, negative 16x. Pull out 3x. Pull out a negative 8. Pull out a 2x. And a negative 1. That's all that will come out of this bottom row. So I would rewrite this. Do not forget about the 2 in front. 2, 3x minus 8, and 2x minus 1 equals 0. Then I just set the stuff in parentheses equal to 0. So I would say that 3x minus 8 equals 0. So x equals 8 over 3. And 2x minus 1 equals 0. So x equals 1/2. So those are the 3 answers that I would be looking for. Number 14, solve by square root. So all of these are in vertex form. I guess this one is not. Number 15. Well, it could be because there's no h. So I want to just solve, I want to get x by itself. So get x by itself. So the first step in number 14 is I'm going to divide everything by 4. And I get x minus 7 squared equals 20. Then I need to take the square root because I want to get rid of that square root. So when I square root everything, you end up getting x minus 7 equals the square root of 20. Then I add 7, add 7. So x equals a positive 7 plus or minus the square root of 20. However, the square root of 20 is not simplified, so I need to simplify it. Think about the roots of 20. I can pull out a 4 and a 5. So if I pull out a 4 and a 5, this becomes 7 plus or minus 2 root 5. That is my final answer. For number 15, want to get x by itself, so I subtract 4 on each side. 5x squared equals 10. Divide by 5. X squared equals 2. Then I square root. X equals plus or minus the square root of 2. And square root of 2 is in its simplest form. The only thing I see people forget is this plus minus right here. When you're taking the square root, plus or minus. Number 16, divide by 3. So x plus 1 squared equals 27. Square root. X plus 1 equals plus or minus the square root of 27. Subtract 1. X equals -1 plus or minus the square root of 27. This is not in its simplest form, so I want to simplify this. Factors of 27, I have 9 and 3. So I can pull out a 3 square root 3. So my final answer would be -1 plus or minus 3 root 3. And then I would leave it like that. I don't know what that's doing there. Okay, so for 17 through 23, we're simplifying. Basically, think about the factors of 50. I have 25 and 2. So I can pull out a 5 square root 2. For number 18, I have a negative inside the square root, so it becomes an I. So I know that I have I 320. And then the factors of 320, we have, let's see, 64 and 5. So this becomes 8 and 8. So I can pull out an 8, I, and then square root of 5 is left over. For number 19, I'm going to distribute the -9i. So I would read this as -18i plus 9i squared. If you remember, I squared becomes a -1. So I'm going to add -18i minus 9. That's my final answer. For number 20, I'm going to FOIL. So when I FOIL this out, I get 8 minus 24i minus 20i plus 60i squared. First thing I do is I change this I squared to a -1, and I can combine my like terms. So I'm going to do this all in one step. I'm going to write this as 8 minus 44i minus 60. I still have two like terms here and here. So 8 minus 60 becomes a -52 minus 44i. It doesn't matter what order you put them in. Anyone will work. When you have I to a power, you need to take that 107, take that power, and divide it by 4. And you end up getting 26.75. So this 0.75 right here just means that it has a remainder of 3. So 4 goes into 107 26 times, and then it has a remainder of 3. So that remainder 3, what that means is that it matches with I to the third. And so if it takes the likeness of I to the third, then that would mean that the answer is -I. So essentially what you're going to do is you're going to take this remainder and you're going to match it with either I squared, I cubed, I to the fourth. It's going to match one of those three. So if it's an I, it's an I squared is -1, I cubed is -I, and I to the fourth is 1. So it's going to be one of these 4 answers. In this case, I cubed was -I. For number 22, remember that you cannot have a square root or an I on the bottom or on the denominator. So you need to multiply by its conjugate, which all that means is you're going to multiply the whole thing by the denominator but change the middle sign. So -3 minus 6i. -3 minus 6i. So multiply that on the top, multiply that on the bottom. On the top, I'll just distribute this 4i So I would read this as negative 12i minus 24i squared. Then on the bottom, I'm going to have to FOIL it. So when I FOIL on the bottom, I get a positive 9. Then plus 18i minus 18i. So you'll notice that the middle will cancel. Minus 36i squared. So once you have that, you can cancel out the i's in the middle. And then I automatically want to change my I squareds to be negative 1s. So I'm going to rewrite this as, kind of running out of room, I'm going to rewrite this as negative 12i plus 24 over, middle stuff cancels, 9 plus 36. So you end up getting, I'm going to just go back and erase this really quickly so I have more room. So if I'm going to combine this, negative 12i plus 24 over 45, then I can simplify. So if I were to reduce this fraction right here, it would reduce to negative 4i over 15 plus reduce this fraction. That would become 8 over 15. So that would be your final answer. I'm going to erase that right here. Okay, lastly, number 23. I'm going to distribute this square root to the top and the bottom. Then I'm going to simplify the top. So if I were to simplify the top, that would become negative, so the I square root 32 over square root 5. I cannot have a square root on the bottom, so I need to multiply the whole thing by the denominator. Then I'm going to multiply across. So when I multiply across, I get square root 5, which is just 5. And then I'm going to take this stuff that's in the radical and I'm just going to multiply them together. So that would become I 32 times 5 is 160. And then the last thing that I want to do now is just simplify this radical. So if I were to simplify this radical, think about the factors of 160. I have 16 and 10, and then 16 is a perfect square. So the final radical, if I were to pull out the perfect square of 16, it would be 4i root 10 over 5. And then I am done. Okay, quadratic formula to solve the equation. You do have to have the quadratic formula memorized. So I'm going to label my a, b, and c. A equals 1, 4, negative 3. Then I'm going to put them into my equation. So sing the Pop Goes the Weasel song. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So first thing I like to do is just figure out what this number is right here. That is under the radical. So I'm going to rewrite this as, you put that in your calculator, you should end up getting 28, a positive 28. If you don't, you did something wrong, so go back and fix it. Over 2. The next thing I do is I simplify this. I simplify my radical. So I'm going to rewrite this again. To simplify my radical, I can pull out a 4 and a 7. So this becomes 2 root 7 over 2. And then lastly, I put my denominator under both terms. So it becomes negative 4 over 2 plus or minus 2 root 7 over 2. Then this reduces and these reduce. So my very final answer, once I have simplified and reduced all fractions, becomes x equals negative 2 plus or minus 2 over 2 just reduces to 1, so square root 7. My discriminant, that is my b squared minus 4ac, so just all this stuff under the denominator, which is 28. Since it is a positive number, that means you have 2 real solutions. Number 25, I want to get everything to one side. So I'm going to move the negative 3 over, and it's going to be a positive 3. So my a value is 6, b is negative 8, c is a positive 3. So then I'm going to put it into the quadratic formula. So x is equal to negative b, which would be a positive 8, plus or minus the square root b squared, which would be 64, minus 4 times 6 times 3, all over 2 times 6. Then I'm going to figure out what this number is. So in my calculator, I will figure that out, and I get 8 plus or minus. You end up getting a negative 8 all over 12. So my discriminant is negative, so I need to figure out what that is when I simplify. So 8 plus or minus. If I were to simplify this, I can take out an I, so it becomes an I, and then also a 4. So 2I root 2 over 12. Then I will distribute my 12, my denominator underneath both terms. So it becomes 8 over 12 plus or minus 2I root 2 over 12. Then I reduce my fractions. 8 over 12 reduces to, if I divide by 4, I get 2 over 3 plus or minus 2 over 12. So I can reduce these and these. 2 over 12 reduces to 1 over 6. So I root 2 over 6. My discriminant would be negative 8, the stuff under the radical. So that means that I have 2 imaginary. Also remember that if it equals 0, so if one of them equaled 0, then you would have 1 real solution. So do not forget that too. None of these do, but if they did. Hint, hint. Okay, moving on to 26. We're almost done. For these, you will use your calculator to graph, because some of these have ugly decimals. So I'm just going to tell you now, if you get a question like this, plug in your calculator and graph. So once you do that, I'm just going to graph them for you. You could also do the negative b over 2a like we did on 1 through 3. But to save time, because this video is already almost an hour, I'm just going to graph them for you. This right here indicates that it is a dashed line. So if it's dashed, it opens up. You're going to graph it like this. Looks something like that. That's beautiful. Then it is a less than shade below, so I'm going to shade below, which is on the outside. This is beautiful. Might use a different color next time. Then if you have a system like this, I'm going to use two different colors. So this first one would be negative x squared plus 4x minus 4. It would be a solid line. So it looks something like this. So that is this one right here. Gonna use red. This graph right here is also a less than. It is dashed because it is not a less than or equal to. And it looks something like this. They are both shade below. So if I shaded below this red one, it would be out here in this area. If I shaded below on this blue one, it would be on the inside. So where they both intersect would be in this shaded area right here. Oh yeah, I like this yellow much better. So it is where they both intersect that you have to shade. I'm going to go back and erase this and use the yellow. This is much prettier. There we go. Use the yellow. That's prettier. You're probably like, what is she doing right now? I have been doing this for an hour, so a little delirious. There, beautiful. Okay, last one. I have negative 5 squared. That means it opens down, but my vertex is at the origin. So it's really skinny graph. Down 5 over 1. I think there is a typo with this. So we're going to just say that it is a less than or equal to. I think that's what I have on my answer key. So then it's a solid line. Then for the second one, it is a 3x squared minus 2. So I have a y-intercept at negative 2. It would be a dashed line facing up. They are both less than, so I'm going to shade below on both of them. If I shaded below for the blue, it would be all on the outside. If I shaded below on the red, it would be on the inside. So the only place that they intersect would be down here. Okay, for 29, it says solve algebraically. So with these, that means that you have to either solve by factoring. You could do the quadratic formula. You could also graph it. You could solve by completing the square. And then take the square root. Either way, any of those options will work. I'm going to erase this just so that I have enough room to work. So I am pretty sure that this number 29 you can factor. So I'm going to try and factor it. So I need two numbers that multiply to get 10 and add to get a negative 11. That is negative 10, negative 1. So I'm going to use my beautiful box method. 2x squared, 5, negative 10x, negative x. So then I can pull out 2x, negative 1, x, negative 5. So I would rewrite this as 2x minus 1, x minus 5 is less than 0. I'm going to erase this. Then my next step would be I'm going to set this equal to 0. So 2x minus 1, x minus 5 equals 0. So then my solutions, when I set them equal to 0, I end up getting x equals 1/2 and x equals 5. And I did that by setting these equal to 0. So I'm going to put these on a number line. They are both positive. They would also be open circles because they have a less than sign, not less than or equal to. So I have, that's open, 1/2, and let's say this is 5. Then I need to test some points. So I'm going to test points to figure out, does it shade on the inside or does it shade on the outside? So I could test, no, I don't like that. I could test x equals 1, and I could test 6, and I could test 0. And then we'll see. But an easy thing to do is just test the middle. If the middle works, then you shade in between. If the middle doesn't work, then you shade on the outside. So I'm going to just do that. So if I test x equals 1, I end up getting 2 times 1 minus 1, 1 minus 5, which is 1 times -4. And so -4 is less than 0 because it's less than 0. So that is a true statement. Since that is true, that means that I shade in between. So since I shade in between, that means that my final answer would be 1/2 is less than x is less than 5. Or if it were interval notation, you would have parenthesis 1/2, comma 5. I think on the test it's going to want you to do it in interval notation. So just remember that. All right, for number 30. Number 30, I think you end up getting an imaginary solution. So you can't factor this. I wish that you could, but you cannot. So if I started doing the quadratic formula, I'm going to say x is equal to -2 plus or minus the square root b squared minus 4ac all over 2a. Well, once you start figuring this out, or if you graphed it, you would see that this right here is actually a -96. -96, that means that you have imaginary solutions so when they are imaginary, that means you have two options. You have either no solution or you have all real numbers. Two options. So how you do that is you test any point. When you test any point, you either get a true statement, which means that it is all real numbers, or you get a false statement, which means that it is no solution. So I'm going to plug in any value. The easiest one to do is x equals 0. When you plug in or when you test x equals 0, if you get a true one, it's all real numbers. False would mean that it is no solution. So I'm going to plug in x equals 0, and I'm going to see if it's true or false. So when I plug in x equals 0, you get 5 is greater than 0. That is true. So my answer would be all real numbers. Which makes sense because if I were to graph this, it would open up. Something like that. And so all of my x values are greater than 0 because x equals 0 is right here. So that is a true statement. If you graph it, then you can kind of visualize as well. Okay, almost done. We're getting close. Number 31, I have roots at -3 and 2. Roots is also another word for x-intercepts, and it passes through 312. So the easiest way to do this would be to put it in x-intercept form, or intercept form, and then also plug in my value to get a. So y equals a, x plus 3, opposite sign, x minus 2. Then I'm going to plug in this ordered pair for x and y, and that's going to give me my a value. So x and y. So 12 equals a. 3 plus 3 is 6. 3 minus 2 is 1. So 12 equals 6a. So a equals 2. So my very final answer would be y equals 2, x plus 3, x minus 2. So I was just solving for a and then getting an answer. The second one is 32, or the next one is 32, vertex. So I want to put it in vertex form. And it passes through x and y. Vertex form, I hope that you're finally memorizing it by now. A, x minus 2 squared plus 7. Then I'm going to plug in x and y. So 2 equals a. 4 minus 2 squared plus 7. 2 equals a. 2 squared is 4, so 4a plus 7. Subtract 7. So -5 equals 4a. A equals -5 over 4. So my final answer would be y equals -5 over 4, x minus 2 squared plus 7. For 33 and 34, that's when you're going to use quadratic regression. In the calculator. Remember that you would have all of your x's in list 1, all of your y's in list 2. If you have an inspire, then you type those in your list A and B. Remember that you have x and y at the top. Then you go to menu 416, which is quadratic regression. That is if you have an inspire. If you have an 84, then you type in your x and y in list 1 and list 2. And then you go to stat, calc 5, which is quadratic regression. Then it's going to give you an A, B, and C value. So when it gives you your A, B, and C value, that just means that it is in standard form. And so you're going to plug in A, B, and C into standard form, and that will be your final answer. Typically, you will get decimals on these questions. So in this case, decimals are okay. I know I say that they're not, but whenever you have regression, that is fine. So for 33, when you do that, you should have gotten 0.33 x squared, it's a negative, plus 1.67 x plus 2. For the next one, you should have gotten 0.0019 x squared minus 0.06 x plus 1.13. And that is just all in the calculator. For 35, this is a maximum height question. So I'm going to show you how to do it algebraically, and then if you want to do it by graphing, that is fine. So we want to figure out what the height is the highest point, and when he reaches the ground. So if I were to imagine what this looks like on a graph, here's my squirrel jumping from a tree. Here's my tree. I'm going to draw a tree. Here's my tree. It's beautiful. At 11 feet. The squirrel is jumping from the tree. He reaches a maximum point and then he falls to the ground. So if I were to label my axes, my x-axis is time in seconds and my y-axis is height. So I want to figure out what this max point is and I want to figure out what this x-intercept is. So to find my max height, I have this equation. I need to figure out the vertex. So to find my vertex, x equals negative b over 2a. In this case, it would be negative 9 over 2 times negative 2. So that would be a 9 over 4. So max is, not negative, just a positive 9 over 4. Then to get my y value, I'm going to take h of 9 over 4, plug it in. It's also 2.25 if you want to use the decimal. But I plug that in, 9 over 4 squared plus 9, 9 over 4 plus 11. You plug that in your calculator and you end up getting 21.125 or 169 over 8, something like that. Feet. So to answer this question, my maximum height would be the y value, so 21.125 feet. And then seconds would be my x value, so 9 over 4 seconds or 2.25 seconds. Then when does the squirrel reach the ground? That is going to be my x-intercept. So I'm going to erase this and show you how to do it algebraically, but you could also do it by graphing. Going to do a little bit of the quadratic formula. So x is equal to negative b plus or minus the square root, b squared minus 4ac all over 2a, which would be negative 4. So you get negative 9 plus or minus 81, 8 times 11 plus 88. You end up getting, let's see, 169 over negative 4. The square root of 169 is 13. So 13 over negative 4. So I do negative 9 minus 13. So you end up getting negative 22 over 4. And negative 9 plus 13 would be a positive 4 over negative 4. And so if I were to reduce this, oops, that should be negative. If I were to reduce this or simplify, you end up getting 5.5 or 11 over 2 and negative 1. However, you cannot use the negative 1. So if this were to continue out here, this would be negative 1 and this would be 5.5. You don't use the negative 1 because that's where he starts. That's not when he hits the ground. And also it would be negative time, and there's no such thing as negative time. So you use the 5.5 and that becomes your answer. You use the right x-intercept. Okay, for number 36, the length of a rectangle is 5 inches more than twice a number. The width is 4 inches less than the same number. The area is 15. So it says length E is 5 plus twice the number, and the width is for less than the same number, so n minus 4. And area equals 15. Area also equals length times width. So I'm going to take my area formula, length and width, and I'm going to plug these in. So area equals 5 plus 2n times n minus 4. And then I'm going to solve. So if I were to distribute this, that equals 15. So I'm going to distribute this, FOIL it. You end up getting 5n minus 20 plus 2n squared minus 8n equals 15. Then I combine my like terms. So I would have 2n squared minus 3n. Subtract the 15 over to the left side. So a minus 20 and a minus 15 become a negative 35. And that equals 0. So I'm going to erase all this, give me some more room. So I'm going to rewrite my equation now as 2n squared minus 8n, minus 3n minus 35 equals 0. And then I want to find that number, so that means I need to find the solution, which could also be my x-intercept. And so I could factor this, I could graph it, I could use the quadratic formula. These are all options. Graph. I could complete the square. Usually no one wants to do that. But in this case, I could factor it. So I'm going to try and factor. I need two numbers that multiply together to get 70, a negative 70, and add to get a negative 3. So those two numbers could be a negative 10 and a positive 7. So I'm going to draw my box. 2x squared, or 2n squared, I guess. Negative 35. Negative 10n. Positive 7n. Then I'm going to pull out the greatest common factor. So 2n, 7, n, and negative 5. So this would factor to be 2n minus 7 plus 7, sorry, because it's a positive, and n minus 5 equals 0. And once I do that, I'm going to set each one equal to 0, and you're going to get a positive and you're going to get a negative number. So you'll only use the positive because you can't have a negative number. So 2n plus 7 equals 0. N equals negative 7 over 2. And then n minus 5 equals 0. N equals 5. You use the positive one, not the negative one. So my number would be 5. Find the dimensions and max area of a rectangle with a perimeter of 120. So you have your length and your width. Perimeter formula, 2L plus 2W. Area, length times width. My perimeter is 120. So I say that 120 equals 2L plus 2W. I want to solve for one of my variables. I'm just going to say let's solve for L. So get L by itself. So I could say that 120 minus 2W equals 2L. Divide everything by 2. L equals 60 minus W. I'm going to take this and I'm going to plug it in for L right here. And then I want to find my maximum. So area equals 60 minus W times W. So I'm going to write 60W minus W squared. And then I want to find the max of this. What is my max? So that's the same thing as finding my vertex. Max, vertex, min, all of that is kind of the same. So I'm going to erase this up here. So if we have area equals 60W minus W squared, I'm going to rewrite this to have my W squared first, because that's easier for me. And then if I want to find my vertex, I could say that W is negative B over 2A. Or X, whichever way you want to think about it. My B is 60. My A is negative 1. So you end up getting 60 over 2, which becomes 30. So if my width is 30, my length, if you remember, was 60 minus W. So length is 60 minus 30, which would be 30. So length is 30, width is 30. So then my area would end up being 30 times 30, which would be 900. Square feet. Good rule of thumb, if it's asking you for a question like this, if you take 120 and divide it by 4, that's usually going to maximize your area because then it becomes a square. And squares will maximize area. It gives you your max area. Okay, 38. Last one. We're so close. It's an hour and a half to do this. Bless your hearts. So, a manufacturer has been selling light bulbs for $2 each. People have been buying 100 per month. The manufacturer believes that for every $1 increase, 4 fewer bulbs will be sold each month. It costs the manufacturer 50 cents to make each light bulb. So this is something different than we haven't seen, is factoring in the cost. Assume that the manufacturer sells every light bulb that they make. So to figure out the profit, because I want to maximize the profit, my profit would be the price that she sells, or he sells, times the number sold. However, in this question, they're giving us the cost. So I need to figure out how much it costs times the number sold. So however much I'm selling them for, and then also I need to factor in how much it costs and subtract that as well. If I were to create an equation from this, my base price is $2. And I'm increasing $1. X is going to represent the price change in price. So if I start out at $2, I'm going to sell 100 light bulbs, but with every dollar increase, I will lose 4 light bulbs. So when X equals 0, that means I have $2 times 100 light bulbs, $200 cost, or $200 price. Then when X equals 1, I increase $1, but I only have 96. So think about it that way. And then cost, so it costs the manufacturers 50 cents to make each light bulb. The number sold is still 100 minus 4X. So I put it here and here. You could also write this as price minus cost times number sold. if you want to do it that way, if you think about it more that way. But it's up to you. So I'm going to erase this. Then I actually want to FOIL this out to get an equation that I can plug in. So if I were to FOIL this, you end up getting 200 minus 8x, because I'm doing it here, plus 100x minus 4x squared, then minus 0.5 times 100 is 50, and 0.5 times negative 4 is minus 2x. Now I want to combine like terms, so here and here. Here, I forgot to put my squared right here. So combine the like terms. I have my profit equals negative 4x squared. Combine the x's. So negative 8 plus 100 minus 2. So plus 90x. Then I have, is that right? Plus, it should be plus 2x right here. So plus 2 would be 94. Because a negative times a negative is a positive. So plus 94x, and then 200 minus 50 is plus 150. So this equation is what I would put in my calculator if you wanted to get your max and your x-intercept. You could also do this the long way, which is what I'm going to be showing you because I don't have my calculator with me. So I'm going to erase this so that we have a little bit more room. So if I want to figure out what the manufacturer needs to sell to make the maximum profit, I would want to figure out what my vertex is. So negative b over 2a. In this case, it would be negative 94 over 2 times negative 8. And you end up getting 11.7. Then I'm going to take 11.7 and plug that in. And you end up getting 702. So once you have that, it says, what should the price be to sell each light bulb and make the maximum profit? So in order to figure that out, if I go back to my original equation, which was the price, it was $1 or $2 plus 1 times x. That was my price. And so if I were to take this value and plug that in for x, that means I would just add $2 to that. So 2 plus 11.7 gives me 13.7. I should sell, or I should charge $13.70 for each light bulb to maximize my profit. When you plug in $13.70, how many light bulbs will be sold? Number sold would be 100 minus 4 times x. So if I plug in x for this, 11.7, you get 100 minus 4 times 11.7, which gives you 45.2. So about 45 light bulbs will be sold. And then what is my profit? That is my Y value, which would be $702. That is what my profit would be. If if you factor in the cost. Seems kind of expensive for a light bulb, but I guess that's what you do to maximize. If you have any more questions, please email me, or you can rewatch this and rewind as many times as possible. We have officially hit 90 minutes, so I'm going to stop. Goodbye.